Great. Thank you, everyone. Again, Shannon, thanks so much for partnering and inviting Aditi to come on this platform and share a little bit about our work and about our organization. Everyone that's on the call, thank you so much for taking the time to join us in the afternoon or evening, and I hope you all have grabbed a drink. So this is going to be a long session, so let's just make sure we are hydrated through the process of whatever your choice of poison might be. I want to take this chance to just introduce through a little bit about Aditi before we go into more specifics around the projects and the research work that we've done. Sandu, if I can just request you to move to the next slide. So very briefly, I want to walk you through a little bit about our journey. We've been in business for 20 years, headquartered from Seattle. And as a lot of companies that are born in Seattle, our founder came from Microsoft. Late 90s or early 90s, he pivoted from there and decided he wanted to start up a product-based company. And that's how we were born. Over the next 10, 12 years, he worked on formulating a product, which is a CRM software, and successfully sold it to a venture capitalist. Mid to late 2000s is when the services industry was taking flight. And so we kind of pivoted at that point and brought in services solutions for our client partners, predominantly focusing on cloud and connected audio services. 2014 is when Samsung got interested in that portion of our IP and acquired that IP from Aditi. Relooking at 2014, we took a step back and said, hey, what do we do? And we do really well. We had done product, we'd done services. So we took a step back and said, hey, the way we add value to our clients is by being a full-blown technology solutions organization that's enabling our partners in their growth process. The two lines of business that Shannon mentioned about, we provide turnkey project solutions to our client partners. And then we also provide talent on demand, which is really scaling up and down your teams as and when you require. As you can see, we're based in, and I mentioned we're headquartered out of Seattle, but have different locations in North America with our delivery and engineering centers out of multiple locations in India and Hungary in Eastern Europe. One of the things that I am super proud to be associated with this brand is over the last 3 years, we've consecutively been recognized as an employer of choice. And that allows us to put the best people and the best right set of people internally as well as externally supporting our customers through the different solutions that we engage and provide them with. Sandu, if I can request you for the next slide. Here's a real brief snapshot of some of the customers that we've been supporting through this course of our journey, and they're widespread, right from technology overall through to hospitality domain and different domains, each one in their own journeys and their own complexities. But what this has really enabled us to see is, as a partner, understand the problems that are specific to their domains, but deal and get exposure and experience with working on problems that have different complexity levels and different scales. And I think that allows us to become really good partners for our clients to share those best practices as well as that knowledge amongst our customers. We'll go to the next slide. Now I'll take a moment to just introduce our team. Maybe should have done that earlier on, but let me start with myself. My name is Swati. I've been in the professional services and consulting industry for about 12 years, lived in 3 different continents, hopped, skipped, and jumped in 4 different countries, and have found my home in Seattle over the past 10 years. I've been with Aditi, it will be 8 years tomorrow. And my role, really, the way I look at it is I'm a connector. So I connect people with opportunities, and I connect my stakeholders who are identifying challenges with solutions. Those solutions could be provisions that Aditi can provide with, or through external partnerships or networks that we may have. I run the account management organization for Aditi and overlook 4 strategic clients, Caterpillar being one of the strategic partners, and they span across different domains and industries. I will hand it over to Jeff, my peer, to take it from here.
Yeah, my name is Jeff Hassett. I've been in IT services for over 21 years now. I started my career up in the Chicagoland area. I was up there for about 9 years, 7 years, excuse me, and then moved down to Central Illinois and have been working with various clients in the Central Illinois area. I actually grew up in Central Illinois in Dunlap, which is right outside of Peoria. And kind of when you grow up in the Central Illinois area, you kind of bleed cat yellow and black, even if you don't work there, because so many of your friends and family do. So I've been really enjoying that. And I guess people who know me best probably say I ask a lot of questions. I'm kind of a curious learner. I have a tendency to ask more questions and listen instead of talking. And with that, I'll prove that by being quiet right now. But yeah, go ahead, DV, I believe you're next.
Yeah, my name is Digvijay Singh Parmar, aka DV. I am head of engineering for Aditi Consulting and have been with Aditi Group of companies for more than 17 years. Majority of my experience has been on building software solutions for various enterprises across multiple industry domains. That's me. Pandu, you can go next.
Yeah. Thank you, Shannon. Thank you, Swati. And thank you all for joining us today. My name is Pandu Rao. I'm a consulting architect, and I've been building systems for about 25 years. Everything from very small scale applications that run on smart cards to very large scale distributed systems. And over the years, I've learned a few lessons, and I'm hoping to share those with you today, and I hope you find it useful. Thank you.
Great, thanks team. Pandu, if I can request you to move on to the next slide. So here, I think we're just getting started to the fun part. Before we roll in, I want to invite DV to just give an overview very broadly of some of the partnerships that we've had and projects that we've delivered across the IoT ML space. DV, all yours to take forward.
Yeah, in the last 5 to 7 years, we have worked with various different enterprises, ISVs, and businesses. And we have solved their data science and data engineering problems. Some of them were really interesting, and the prominent ones are on the slide. The T-Mobile, it is a telecom company, and we are engaged with them on their data science and data engineering needs for assets, inventory, and cellular data. Microsoft is an ISV enterprise, and we have engaged with them on various data science projects in the past. One of the interesting projects that we executed was on their data center recommendation. The recommendation was when to actually build a new data center or to expand a current one. So that was a quite interesting project with Microsoft. Next one is Target. Target, as you know, is a retail company, and we have helped them on building a predictive model to detect fraudulent transaction for cell phone transaction at real time. Moving to ZONAR. ZONAR is Auto Fleet Management Enterprise, and we have helped them on various fronts, starting from creating intuitive UI for business insights to predicting vehicles for expected repairs in next 90 days based on the driver and the vehicle history. The next one is Wilbur. Wilbur is an agriculture company. Based on soil sensor data and heat map clustering algorithms, we have built recommendation engine for variable fertilization, which is key to the precision farming. So those were 5 quite interesting projects that we have done in the last 5 to 7 years. In today's session, we have picked up 2 case studies. One is ZONAR and one is Target. And I will now hand it over to Pandu to do a deep dive session on them. Pandu, all yours.
Thank you, DV. Yeah, so as DV mentioned, Aditi has designed and developed systems for multiple clients. So why did we choose these case studies in particular? Well, that's because of the comparable domain and scope, the multidisciplinary teams, significant technical and logistical challenges, useful patterns that emerged from the work that we did, And there are a few interesting stories. So that's why we picked these particular case studies. I think it was Lenin who said, there are some decades where nothing happens, and there are some weeks where decades happen. Some projects are like that, where everything happens. You go in as an engineer, you emerge an architect. You go in as a manager, you emerge as a leader. You go in as colleagues, and you emerge as friends. And some projects divide your career neatly into two, everything before and everything since. So for me, ZONAR was all of this and more. I hope what I say here today does justice to the extraordinary work that was done and the remarkable people who endeavored there. So many years ago, I used to live in Michigan. I won't forget the winters. And I won't forget how in the dead of winter, you had snow plows, garbage trucks, school buses, everything running on time. It was much later I realized that they had two things going for them, which is hardy, hardworking people and robust and reliable systems that were supporting them. And some of that reliability came from ZONAR, and the company was based out of Tukwila, Washington, but I didn't know that at that time. So one bright summer, I think it was spring afternoon, okay, we found ourselves seated in ZONAR's boardroom. Across from us were their executives, both founders, along with some exceptional engineers who had risen through the ranks. On the walls were plaques outlining their various patents, and the people behind those patents were in the room that day. Our introductions behind us, we settled down and we wanted to give a little bit of background on Aditi. That's when the CTO interrupted and he said, not to be brusque, but skip the slides. He continued, okay, here's the problem. You have 250,000 devices on an exponential growth trajectory, sending data every 3 seconds, round the clock, and you have large customers in multiple countries. Okay, we have strict SLAs and penalties for lost messages, and we need sub-second response times. Are you telling me you guys can do this? So this is where I committed the professional equivalent of hold my beer. I faced him, then grinning, I said, channeling candidate Obama, yes, we can. He was genuinely amused. Okay. So with the faintest of smiles, he continued, I must tell you that the last 2 vendors who attempted this failed spectacularly. Still interested? So now I'm already in hold my beer land. Okay. And it was double or quits. So I did whatever any insane person would do and double down. And channeling candidate Sarah Palin, I said, you betcha. So at this point, I'm thinking, okay, there goes your career. You have no political future. And worst of all, you didn't even finish that beer. As I'm waiting for everything to devolve, the demeanor of the room changed. Okay. The tension eased, and the CEO, who was quiet until that time, spoke up and he said, I like this guy's confidence. The CTO turns to me and says, tell you what, you prove to me and my team here that you can build a high performance system. Impress them, and I'll consider engaging Aditi. So we walked out of the room that afternoon with 3 things. A challenge, a promise, and a handshake. All the makings of a great adventure. Now, without a doubt, large projects have many challenges. So we prefer to work in terms of a framework. Okay. So what we do is we divide the challenges into abstract and concrete. It's the broadest division we can think of. From our perspective, there is definitely some uncertainty, possibly some complexity. So we have to deal with that. From the client side, they been exposed to the domain for a very long time. So they think in more concrete terms. So they have metrics, okay, and various manifestations of problems. Okay, they may have even solved many of the problems, but from our fresh perspective, we don't know what we are dealing with. So it helps to visualize. Let's say create a concept diagram. If this looks confusing, it's intentional. When we go into a project, it roughly looks like this, but this is a very thin sliver of the entire problem space. They tend to get very large. Okay. Let's take this seemingly simple case. You have a customer who has some device that is mounted on some vehicle running around somewhere in Alaska. It's generating data. The data is subject to regulations, which have to be managed by operations. And the database is getting populated. The operations have a mandate that they should manage costs. So they have to delete data to recycle the disk space. But the data may be subject to a legal hold because one of the customers is undergoing a regulatory audit. So that data must be exempt, and so on and so forth. Every time you think that you've got an idea of where to start with a problem, okay, it gets even more convoluted. So on a good day, it feels like the concepts are all working in concert for you. On a bad day, it feels like they're all conspiring against you. And on some days, you can't even distinguish between the good and the bad. Now, it's tempting to solve the larger problem at this point, or even some portion thereof. Anything to make sense of this madness. Okay. However, caution is recommended, for the entire affair is delicately balanced. The right move, in fact, the only move, is to formulate a problem statement. Let's pause and ponder for a moment. Without a problem statement, there really is nothing to solve, nowhere to go, and no course to correct. Hemingway cautions us by saying, do not confuse movement for action. And Fred Brooks Jr., the author of The Mythical Man Month, says, the besetting mistake of an expert designer is not that they will design a thing wrong, but that they will design the wrong thing. So we stay in this state until things become clear. For how long? Well, that depends on the problem. If we frame the problem statement correctly, the proposed solution generally follows from the problem statement. In this case, it turned out to be a distributed system that provides all of the existing functionality of the flagship system and exponential scalability at linear cost. So we know what we are building, but we don't know how we are going to do it. That brings me to 4C. Now, if I had to conduct a one-week workshop on architecture and design, and I had just one slide, it is an arbitrary constraint, but let's take it for argument's sake. Okay. This would be the one slide I would pick, and believe me, I can talk for a week on this. Okay. Here, the focus is on the how, okay, not on the what. We proceed to build a thing that is correct, clear, concise, and composite in that order, and moving from one stage to the next only if the current stage has been satisfied. Okay. We strive to build something correct and prove that it works. Okay. And we could use prototypes or models with test cases or something. Today, you could even use something like TLA+. Once that's done, we aim to communicate the system to others so that we have a unified and shared mental model and a clear specification. The objective is to facilitate a criticism of the design of the system. When we have addressed all of the criticism and revised the design, then we distill the concept into its most concise form, its very essence, basically. Okay. We do this to reduce the accidental complexity and to reduce the attack or failure surface area so that we may better examine the second order effects that creep into these systems. And finally, so that others may not reduce it further and claim it as an innovation. If you're going to file for a patent, the last part is important. Once all of this is done, we ensure that the system is in its composite form, which means it may be linked to others in a form where you can create something where the larger entity is more functional, more useful than the mere sum of its parts. Okay. You probably noticed that there are 5 C's here. So the inside joke is that there's a bunch of programmers who put this together, so it's a one-off error. Okay. To summarize, okay, correct, clear, concise, and composite. It leads us to complete, or does it? What's the question mark doing there? So, well, that's to remind us not to get too arrogant in what we believe, okay, or to think that we may be able to foresee perfectly. So a little bit of humility is recommended at this point. So we go through this process following the usual things, the discussions, the arguments, the documents that are written, the code that is written, design review, code review, weeks and months of this. After a long time, we have something that we can consider worth implementing. So moving on to the implementation aspect. So many talented people working for many weeks, say many months, okay, we finally ended up with an application that looks like this. I'm pleased to say, but dare say, we exceeded the bar set by ZONAR. With an application like this, ZONAR's customers could get a comprehensive look across their fleets, vehicle metrics, regional aggregations. Most of this was previously impossible. Okay. The application had an enterprise-grade security model, roles, ACLs, default screens, fully composable UI. All of this is card-based. You can take one card out, you can build something else with it. So each little card had a data store backing it, so you could compose any screen that you wanted. Okay. So the ZONAR managers were beginning to describe it as an elegant system. And if you look under the hood, you've found something like this. There's a lot to unpack here, so we'll do it in 2 passes. In the first pass, I'll give you an overview of what's here. And at the end of the talk, I can dive into this in a lot more detail if that's required. So what you see on the left is a macro view. You have a vehicle with a telematics device moving data over the internet, going into ZONAR's data centers. And once it's within the data center, it gets processed by the, there's basically a data pump that processes it and stores it in the storage cluster. And later on, when you have users coming in from the browser, it accesses the same storage cluster and surfaces the data and renders it using AJAX or REST API, what have you. So this is effectively it. Like I said, we can dive into this in detail if there is any interest. So what was the impact of building this? Okay, so firstly, their platform strategy was validated. Now, these are good engineers. They had built a platform that had lasted 10, 12, 13 years or so. Their customers were asking for certain things, which there was some nervousness whether it was possible or no. But when we came in independently and built the system, that gave everybody the confidence that there is a path from their existing system to a new world, and we had proven it. Okay. As a result of that, their enterprise contracts were renewed, and the previous architecture, I think they were using only 1 or 2 data centers. With the new architecture, they had a truly distributed approach where they could have multiple rings across, one on the eastern seaboard, one on the western seaboard, and then you would have business continuity ensured. There's a quote from Beth Brinton, the president and CEO. Okay. For us, this was a dream come true, and it was for all of us. So that's the ZONAR project. The target project too has interesting stories, but I won't go into them here for reasons of time. But there's one curio at the bottom of this screen, which is a SQL statement. It is one of the only 2 SQL statements I wrote that year, making it, for me, the most expensive SQL I had written. And this was only one of two sequels in that particular project. The other one was a logging sequel, so it doesn't do much. But the heart of their fraud detection engine had a sequel somewhat like this. It's not the exact sequel, of course, but it had something like this. So it is a curiosity. Okay. Again, we approached this project by dividing the challenges into the abstract, into the concrete. What do we know? What do we not know? And how do we move forward? Okay. As before, we would create a concept diagram, see what links to what, and try to unravel the Gordian knot. Okay, I won't go into that again because it's very similar to the other one. Okay. But the focus is still on framing the problem statement. Okay. So let's take a moment to ponder here. And let's get something simple out of the way first, omni-channel. Okay. A target, for example, you can have a transaction coming in through the point of sale system, or through a web browser that a user is using, or through third-party kiosks that are deployed in malls. Okay. So they would classify everything as an omni-channel transaction. Okay. So that's the simple part. However, there is a particularly devious thing hiding in plain sight in that statement. Okay. And that is the word probabilistic. That single word transports us from the domain of deterministic computing to that of probabilistic computing. The implications are not merely technical, but it goes right down to the heart of how service contracts are written. Okay. Imagine the project fails, and this is how a conversation would go in their boardroom. They'd say, you spent how many millions on a fraud detection boondoggle that cannot detect fraud? It's a difficult question to answer. So how do we approach problems like this, okay, that are fundamentally probabilistic, they are high risk in nature, you don't know whether you're going to succeed when you set out on the endeavor. Okay. So what we do is we employ something called a domain space scouting system. Okay. It's basically an approach we follow, where you have a small focus team with a charter to explore the problem domain and see what kind of solutions are possible in the solution space. And they document whatever they have learned. The team works for about 2 months or so, and they return with an answer to a few questions. Okay. So the questions are, is the problem as defined solvable? If yes, how? If no, why? The team is neither rewarded for a yes nor penalized for a no, but they do stake their professional reputation on the report that they provide. Now, domain space scouting makes it possible for us to compartmentalize risk and minimize the cost associated with it. We can sequence the effort and write conditional contracts. So you can say, if we succeed in this part of the project, we will get the next part of the project. So if by chance we fail to deliver on a very small portion of the project, okay, we don't jeopardize the entire project. Okay, we don't overbid, and then it doesn't look bad. Okay. So we use these mechanisms to isolate the probabilistic risk on many of the projects, okay? And we try and repurpose the salient portions of the system. Maybe there is some part of it that is useful even if the main portion fails, okay? So, okay. So let's look at the solution itself. Okay. So what we do is we analyze historical transactions and extract features from them. And out of that, we build a machine learning model. Then we process new transactions using the machine learning model, and we predict the likelihood of fraud. And then we interpret that prediction using certain business rules. So the proposed solution turned out to be fairly simple and straightforward at this level, but the operational aspect is the risk associated with this. Okay, that was still unknown at this point. So we created different efforts. One, to analyze just whether it's possible to predict fraud. And that team succeeded, so it paved the way for the rest of us to go build the rest of the system. So the implementation finally looked like this. This has no UI. It's just an API call that can be called by any omni-channel client. Okay. You have the operational data that is processed and it's stored in the cluster. You have a new transaction come in, It makes a call to the streaming data service, okay, which uses the stored data to determine if the transaction is fraudulent. If it is, it gives it a score. And then based on business rules, you determine what you want to do. Okay. Do you want to process this as fraud, or do you want to process this as a safe transaction? So that's entirely up to the business. As a result of this, that year, Target was able to scale to meet the Black Friday traffic. We did other work on another platform for them. So together, they were able to meet the Black Friday traffic. And they were even able to process up to 250% of the previous peak throughput. Okay. And finally, I think last year, November or so, I spoke to the director of engineering there. And he informed me that the system was still in operation, okay, 25,000 continuous hours of error-free operation. They didn't need to do any maintenance. Their entire maintenance team had come down to one DevOps person who was just making security patches when you have when the OS components are fixed and so on. Okay. So that's what we did for Target with Project M. Now, ever so often, the Aditi's domain space scouting team is tasked with identifying trends in technology, analyzing them, cataloging them, okay, and documenting what we learn. Okay, we frequently put out blog posts and white papers, etc. Okay. And the outcomes of these exercises are not your lightweight reports written by industry analysts who talk to other industry analysts in a hype-saturated echo chamber. Okay. These are field reports from the trenches reflecting the trials and triumphs of technologies. What works, what doesn't work, what looks like it's working until it's not working. So when clients are considering emerging technologies, we can help them take informed decisions. We can say, here is our understanding of the space. Here's what we have learned. You may want to be cautious when you approach this particular technology. Okay. Take computer vision, for instance. Okay. The industry as such has spent about $80 billion on self-driving cars and the computer vision aspect of it, let's say. Okay. What's the crux of the problem? Why is it so difficult? Okay. We wanted a representative problem in that space. Okay. Something a little more difficult than your garden variety facial recognition, and something more practical than identifying animal species in suburban households. Something that goes beyond 2 dimensions, because in computer vision, all of the interesting problems are in 3-dimensional space. Okay. So we settled on identifying the extent of damage on vehicular surfaces. Okay. So I'm going to move now to another application to walk you through what we did. Okay. So I'm going to pull up. So here is a data set of representing a Camaro. Okay. Now, if you were setting out to discover structural damage, okay, I can tell you it's already structurally damaged. So you can say vision accomplished and be done with it. Okay. However, it turned out there's a bit more happening here. Okay, so we unpacked the data set, we manipulated it in different ways, etc. And finally, it turns out there is indeed a Camaro embedded in that data set. Okay, now what you're seeing here, let me change the color here to make it a little more. What you see there are points. Now, how this image is constructed is by pointing a LiDAR camera, which shoots a beam of laser at any object, and the laser bounces back to the camera, and they look at the time of flight or some other metric to see and map it out to a 3-dimensional space. So what you get as a result of using that camera is a metrically accurate representation of 3-dimensional space or a 3-dimensional object. Now you can do this for anything. You can do it for landscapes. Okay, you can use it to discover lost civilizations. The applications are endless. Okay. So in this data set, if we were to assume that there is a small damage, okay, on the fascia of this automobile. Okay, let's say a golf ball size damage, okay, 43 millimeters in diameter. Okay, is it possible to use computer vision techniques to detect such damage? If so, what would the architecture of such a system be? So I'll briefly walk through the architecture of what's involved, and then we'll look at the application doing it. So let's say you have a data set with X, Y, Z points. That's generally what you get, 3 points in 3-dimensional space. Okay, you send it through a pipeline. Okay. And in certain cases, you might have images of that car, in which case you can augment the data set in certain ways. In this case, we didn't have RGB data to augment that data set. So we directly move on to what we call intrinsic augmentation, where we study the surface of the points in the LiDAR point cloud and see what represents a structurally intact object and what represents a damaged object. Okay. And we pass that through we study these fragments, and then we know how to detect damage. And then a neural network, what it does is it analyzes each descriptor and it finds out whether a particular point belongs in a damaged cluster or an undamaged cluster. Okay, so that's the prediction that this neural network makes. It's a fairly complex environment to replicate, and to facilitate that, I've created a video. So I'll play that, and I'll walk you through what's happening as the engine is progressing. So you can see there's a simulated damage right here. And then the engine starts. Now what you're seeing here is, as the neural network is analyzing the various fragments that compose the LiDAR point cloud, it's going through and scanning it. And it scans, if there's no damage, it moves on. Okay. Since point clouds are generally unordered, there is no way of saying what fragment is going to get scanned next. Okay. All of this is happening in parallel. You can increase the number of processors you want to increase the speed. We found a good balance between performance and cost, and it takes about a minute for it to detect the damage. So as it approaches the fascia, okay, at a certain point, it recognizes that that particular cluster is damaged from the reference point cloud. It goes through and it scanned everything. There's nothing more to scan. Okay, so that's the demo. And thank you. If there are any questions, I'm happy to answer them.
I know I have questions. How about anybody else? No? Well, I'll go ahead. So I'll start with the last example that you did and maybe work backwards. I do have several questions. I'm looking at the application. I'm thinking about the application of the neural net and actually doing the computer vision. And I see that as really having some great opportunity or application. I'm thinking of like an insurance company. I could see an application there. I could also see maybe quality control in a factory and trying to look at the imagery there to make sure it was built right and there weren't any incorrect. Do you think that would apply, or have you seen that in the work that you've done? Yes, and this is a really good question. Okay, it's a question I didn't ask before I built it. Okay, so after we had built all of this, okay, we're just doing research to look at industrial applications to see if there are customers who might be interested. And it turns out that there is an insurance company in Chicago which has data sets going back to the 80s of images of damaged cars. Okay, and so wherever in the US cars have been damaged, okay, those pictures have finally ended up in their database.
So 5 years ago, they were perfectly placed to take advantage of the development in neural network modeling. And they know how much they spent on each damaged image. Okay. So when they have a new car that comes in today, okay, they can say, okay, this is the damage, this is the reference, this is how much it cost, and they can score by that. And they have a system in production. I forget the name right now. It was, but they are a Chicago-based company. I can send you the details after the call if you're interested.
That'd be interesting. I'm thinking of like Lemonade, which just went public recently. It's an online insurance company. They brag about being able to settle, you know, different issues that get turned in or claims that get turned in fairly quickly. And I would think some type of technology like this would help that company, you know, do business in a less costly and more efficient way, and also get people their money faster and be fair, right?
Exactly. And there's another point I wanted to add, and you reminded me, which is in manufacturing, you need measurements to be metrically accurate. Okay, and LiDAR and in the three-dimensional fidelity that you get allows you to make precise measurements. Okay, to see if there are any variations in the surface or volumes. I've seen this technique being used in measuring the amount of ore that has been mined in, let's say, in a certain area. Okay, so there's plenty you can do just by measuring volumes, and that's an easier problem. You don't even need a neural network to do that. The other application I have seen is, let's say after a hurricane, if the landscape is damaged, they can do before and after analysis of the landscape to see which is the most damaged area, and using simple things like Hausdorff distance between 2 point clouds. Okay, so it's possible to do a lot using three-dimensional data, but again, it's all in the, these are early days for 3D computer vision. Okay, even $80 billion behind us, there's a lot we don't know.
Yeah. I'm wondering, oh, I'm sorry, was somebody else speaking? Go ahead.
No, Shannon, I was saying there is another example, you know, with the rental car agency, they can definitely use this. Right now, sorry, they visually, you know, inspect, you know, whether there is any defect on the car or not when you are driving a car out of the lot. And then where you are bringing in, they again do the visually, whether you have damaged the car or not. With this application, you know, it is all automatic. When you are driving out of the lot, all these cameras can record the image. And then when you come back, it records the image back and see whether you have brought back a car without damage or with damage.
I like that.
That is one. And the other one I was just thinking about, and Pandu, I don't know whether you remember or not, we were engaged with a local company which makes aeroplane spare parts. And the way they actually test is they test using molds. So rather than using mold, they can use this, you know, computer vision for sure.
Yes, yes. Yeah.
Interesting. And going back to your rental, I swear there was one time I rented a car and they came back and said, hey, it was damaged. I go, I didn't damage it. Like, well, you have insurance anyway, don't worry about it. And I think they're trying to get their money back on somebody else that had damaged the car. I would have liked to have one of those visions ahead of time to prove that I didn't damage the car. So not only just for the rental car, but for the person running the car. I'm wondering, you know, I was watching, of course, with all this COVID stuff, right? You get extra time to watch some TV. And one that I love to watch are the Discovery channels. And there's one show on there, and I think it's on the Disney Discovery, whatever. They go back and they look at history and they look at old cities, and they were able to go in and actually build up images of what that city looked like. They could do it because they did some type of imagery of what was underneath the ground. I'm wondering, is this the same type of technology to do that and bring a city to life and prove history and where things happened?
Yes, exactly. So there are a couple of different things that can be done. You can mount the same camera on an aircraft, and you can fly it overhead and get a completely faithful rendering of the 3D landscape under. You can see individual light poles, you can see the catenary of the electrical cables, or you can mount the same camera on the backpack and walk through a jungle and it can use ground penetrating LiDAR to discover lost cities. You can mount it on the underside of a boat, and there's something called a bathymetric LiDAR that you can use to look at undersea scapes. Okay. So lots of applications, and in fact, almost any large infrastructure project, they always do a LiDAR analysis first with fully documented look at the landscape, okay, where the bridge is going to go, where the clearances are. They do all of this, okay. However, it doesn't register so much in the computer vision space because the technology is not at a point where you can do complete automation. Okay, there's a lot that humans do today using these systems that may be essentially irreplaceable. Okay, we do not know. Like I was saying, right? We live in interesting times today.
You do, right? Things
Yes.
are changing fast.
Yeah.
Yes.
There is another example that I can definitely think is doing a topographic survey for getting permits from counties. This is a very tedious process, and the topographic surveys are not very cheap. They are very costly and very time consuming. So with camera, probably on a drone, you can do easily topographic surveys.
Yes. Yes, I think there is a company, either Eagle View or something like that, that does something very similar. Yes, they're using drones. But again, there are serious drawback to using drone and 3D imagery and stitching them together. They're not metrically accurate. As much as I like the idea, at certain points, images don't work. And stitching images together doesn't give you the necessary fidelity for the accuracy that you would need for certain applications. So depending on the application, you can choose to use images. At a certain point, you'll say, I need something more accurate. I'll go to LiDAR. Okay. So use whatever technology you think will solve your problem for you. It's not a good idea to bet on any single technology right now. It's better to use a scattershot approach right now.
Yeah. Interesting. Anybody else have any questions or ideas on that or thoughts?
Well, Shannon, I was just going to ask, so I've worked with an insurance company for a long time here in Central Illinois, and you talked about Chicago, and I was kind of curious, they have taken a lot of competition from, other insurance companies that are more e-commerce or whatever, web-based. How can they leverage this technology to, sort of get themselves either back in the game or ahead of the game type of thing? What are your thoughts there?
I can tell you how this particular company used the technology and where specifically. Maybe that will address your question. So in this particular case, the technology comes into play after an accident has happened and when you're trying to do insurance adjustment. Previously, I remember when you'd have an adjuster come to your house, he would take pictures from many different angles, he would mark it up in paper, and then it would go into their system. And a few weeks later, you would get a quote saying that we have totaled your car or something like that. Okay. Today, what they can do is they can tell the customer, yes, you had some damage. You take us pictures from these different angles and you upload them to our server. Okay. And then it's going to be processed by their system. Of course, the customer is going to tell them that this is the make, this is the model, this is the year. Okay. And based on that, they can narrow down in their database and see, do we have something similar that matches what the customer is sending us? If yes, let's look at the degree of damage and see if we can give them a quote. Okay. If at any point they're not able to find a match, they can simply fall back to their old system of sending an adjuster. So now they're a little more efficient about when to actually send an adjuster. But before that, they had no option at all. They had to send an adjuster out for everything. Yeah. So that's an example of where the technology has used. It's made people's lives a little more easier. Hopefully, it's reduced the workload. Okay.
Unfortunately, I've experienced that. But yes, well, thank you. Appreciate it.
Sure.
So I had another one on the example you gave at Target. And as I think about Target, I'm thinking back to the news and some real serious hack that Target had. Was that what motivated that project? Because I know Target got hit pretty hard, and you know the cost of having bad security. I mean, you can lose your company over that. Is that the driver for that project?
Only partly. But coincidentally, we were invited just after Target ran into that huge hack into, I forget the exact year, okay? But they did a comprehensive review of their entire company. I think they went to an ISO security spec or something like that, okay? But they became very, very strict about security. So when we started out, they said, okay, this is the bar you have to meet, and they gave us a big manual. Okay, you have to make sure you check every box in this. Okay, so we have built systems like this many times before. So it's baked into our processes as well. So we went through it and said, okay, everything that we do is going to cover most of what they're asking for. There's a few, there are small deltas, and those we can reconcile by either negotiating, or we can modify the architecture in some way. Long story short, we met every one of their security requirements. Okay. And with IoT, security is extremely important, because these are systems that you once deploy, there's nobody monitoring them. So if they're compromised in some way, it can pose serious problems. We've seen that happen in other places, right? You have webcams that have been compromised to create DDoS attacks. Okay. So almost everybody in the security industry is worried. In fact, I'm reading a book right now that says, click here to kill everybody.
Oh, gosh.
It is that scary.
Yeah.
Okay.
So
those of us who are working with IoT devices, sensors, and building modern systems, there may well be a time where every one of these things can be commandeered by malicious people. So we have to think of how to build systems that are resilient to all these kinds of attacks. We don't know what the correct approach is right now, but everybody is in that state of mind, okay? And they say only the paranoid survive. So right now, that's where we are.
That's great. Well, I know Target seems to have recovered from that hack, because I think during COVID, their market share has gone up, and I think that their stock price has gone up as well. So I think maybe your project was successful just if you look at their stock price. So
yes. So internally, there was a change in the mindset also, and for the better. Okay. Once an organization understands that security is not something that you can add on at the very end.
No.
Okay. It is a process that has to be baked in from the beginning, and it has to happen every day. There are regular audits, all of that. So once it goes into the cellular structure of an organization, then it has a chance of handling new threats that come their way, building systems that are resilient. Okay. So good things did come out of it finally for Target. Okay. And we were there as the change was happening, and we understood it. Okay. And we took everything in stride. Okay. And they appreciated it.
That's great. Awesome. Anybody else have any questions about the Target example? I'd like to move towards your first example that you gave, and that was dealing with your IoT and the ground traffic control. Having worked at Caterpillar and worked in IoT, and bringing a project from the beginning all the way through to production and commercialization, I know we ran into some problems. So one of those was, if you could help me understand, did you guys actually build the telematics device itself that went onto the vehicles? So not the device itself, but we were familiar with every aspect of it. So for example, the protocol that they were using, okay, the data structure of the packets or messages that were moving back and forth, okay. We had to understand every aspect of the system before we could build the first aspect. Okay, so that's one of the reasons why we were extremely cautious in the initial weeks, saying until we understand this and there's some solid ground for us to step on, okay, we are not going to the next step. Because if we miss something here, it's going to manifest itself way down the road, and we won't have time to correct it. Okay, so yes. So you didn't actually do, so I know with the telematics devices, I know some of the issues that we had, one is making sure we get all the certifications and all the testing for emissions control. There's also a lot of different certifications you have to get for cell. And then if you go to different countries, trying to get all your countries certified, there's a very, very long process and a lot of challenges. Security, definitely, I agree with you. Starting from the beginning is extremely important. And that was like the first thing that we did was we started with security before we built anything. So understanding back and forth. And I think you had, at least you and I, when we talked earlier, you were talking about that. So the next question, did you run into any challenges with self-service not being available? Because that can be available when somebody drives into a tunnel. For our case, they could, you know, our machines and engines are all over the world, so they could go, you know, they just go dark for some reason. They just mess with all connection.
Yes, that's a really good question, because one of the things is in a distributed environment, anything can fail at any time for any reason. You have no way of knowing whether something has gone down because you lost connection, whether it's an intermittent connection or a long-term drop. Okay, so you have to build a system where you have to assume that any endpoint is not going to be functional. And you can't even tell whether it's an intermittent connection or a fundamentally broken down connection. Okay, and you need to be able to recover from that errors. So here are a few things that you can actually do if you're building systems like this. Okay, first is on the sensor itself. Okay, you can use circular buffers to store data for, let's say, 2 weeks or 4 weeks. Okay, and you override the buffer if it crosses that threshold. Now, if you lose cellular connection for any reason, you're still queuing into that buffer. Okay. Over a 2-week time period, if your cellular connection is restored, then you start popping from that queue and sending the data. When it comes to the server persists it in a durable queue and sends an ACK. Until the client receives an ACK from the server, it must never delete any data. Okay. So now there's a chain of custody for each message. If it's persistent, it will be somewhere in this chain in the distributed system. Okay, so only an ACK can delete a data element from the client. Once it comes on the server, once it's persisted, it immediately gets replicated across different data centers, across different geographies. You'll have something called a canonical data store. Okay, the nice thing about time series data is there is temporal ordering, okay, and it is an extremely elegant way of storing data. Okay, all you need to do is say that to microsecond or nanosecond precision, you will find a slot in this append-only journal. You insert the data and you move on. Okay, now let's say for some reason a particular device is not able to send data. Okay, so that's fine. When it comes back again, when the pump is processing the data, it gets written again based on the temporal order itself. Okay, so there is one for durability that you write, okay, but that is not the canonical data store. The canonical data store is you reprocess it such that you can replay your entire log, and you will have what's called idempotent processing. Okay, so you can replay the same data time and time again, and the database will enter the same state every time. So you can recover from any error.
Great. Okay.
So using these principles, sorry.
Local storage.
Yes. Yes.
You're storing data at the edge, and then you're collecting it back into the time series sequence.
Exactly.
Yeah. Okay. So another question I was thinking about was, okay, so now you get all this data back, right? And well, one question is you can choke on the data because there's lots of data. Did you have to do anything to try to minimize the amount of data that you were pulling back or storing?
No, we didn't have to throttle any of that data. So the way it is built is, since we're assuming that there are millions of devices, so at a network endpoint, you'll have very little time to read and store it. Previously, they'd probably store it in, let's say, a relational database. Now, a relational database is optimized for reading. So when it gets written, the indexes are updated, so the B tree is updated. So that takes away precious milliseconds every time data is persisted. So you shouldn't introduce a relational database in the queue for when data is entering your system. What you do is you take it and you persist immediately in a queue. A queue does not have to carry the overhead of maintaining that index.
Mm-hmm.
So within very few milliseconds, you'll be able to send an ACK back to the device. So that allows your servers to keep as many ports open as necessary. So you shrink the time window for which a port is bound to a particular device. Okay. Now what you can do is you can create a cluster of these. You can throw in a big IP gateway, and you can put as many queuing clusters behind as is necessary. And you just monitor the queues. If your queue is growing large, that means your pump is struggling in processing the data. So now what you do is you add more workers to the pump. When you have a system like this, what you effectively get is just by monitoring the size of the queue, you will know whether your entire system is operating to spec or if it's struggling at some point. And whichever point it's struggling, you just throw in another system into that cluster. So we had built it so you can insert a new node or take off an old node or tear down the entire cluster at any time that you want.
Interesting. Okay. All right. That was good. Another thing with the data, did you guys do any complicated analytics with it, with trying to do predictive analytics or diagnostics or prognostics?
Yes. So the first thing is ZONAR had done an evaluation of what they wanted their data store to be. They had chosen Cassandra. So what that does is it fundamentally changes the way you think about storage, persistence, and retrieval. See, when you have a relational database, you say, this is the schema. I'm going to write the data in this schema. And much later, when I have a better idea, I'm going to write a query against that table or those joins. Now with Cassandra, you don't get to do all of that. You should know beforehand what you're going to read, okay, and how you're going to read it. For example, the entire Cassandra cluster is organized as a ring, and there's no way of saying which data element is on which of these nodes. The only thing that it guarantees is that I won't lose any data, okay? And the other thing you cannot do is you cannot do a table scan, okay? So you can't iterate over the entire Cassandra table at all, okay? So you should know exactly what you're looking for and how to specify it before you do anything else. So you have to turn your designing approach upside down and look at it from a consumption point first, and then build the data structures to meet some consumptive schema. Okay, so that was the interesting aspect about working on persisting the data in a format that can be later analyzed. So now what this does is anytime they want to run any analytics, they have to know well in advance exactly what they want. So they would tell us, these are the analysis we are going to perform. Then we'd say, okay, this is the table structure that supports that analysis. Then we'd write the components that did the analysis, and it would, now once they know what they want, you can create the workers that automatically do the analysis and keep it ready for you. Okay, so for example, daily aggregations, monthly aggregations, or yearly aggregations, it would simply run aggregate. So the moment they wanted to know, how's my fleet performing this month, okay, you could just read one row in that entire database and it would tell you exactly what you're looking for. So that was the complex analysis that was done. And that's how Cassandra was structured to support those analyses.
So if you decided that you wanted to come up with a new analysis, would you have to rewrite everything or like restructure the whole database? And
No. So we have taken that into account. Okay, but let's assume that the case is that they've come up with an absolutely new metric that we had never considered. Okay, so we'd say, what are the underlying elements you need to support or generate this metric? Obviously, it has to be somewhere in the database. Okay, so we had created layers of tables that you can say, if this is what you're looking for, you are going to find it in this layer of the schema. Okay, Okay. The only thing is you would have to write a little bit of code to get it. But once you were able to extract it from there, you would automatically formalize it as a worker and put it inside the cluster. So the next time somebody wants it, it will generate it automatically.
Okay, great.
Yeah, and to adding, what Pandu said, Shannon, we also did a predictive modeling for them. So based on the vehicle history, the inspection it had, and based on the driver associated with the vehicle, we could actually predict what kind of expected repairs would be on this vehicle in next 90 days.
Okay. All right.
Yeah.
Good. That's great. All right. So I know we're getting into the time here. It's about 6:45. I just want to see if anybody else has any questions or comments. This has been a fascinating discussion, and I really appreciate all the depth and detail that you guys have got into. So, and the projects are each one of them has some really nuggets of knowledge in there. Does anybody have any questions? I'm looking over to the group. Okay. Well, you guys, if somebody has wants to know more information about Aditi, where do they go to find out more information about Aditi?
Let me pull up the slide deck 1 second. I'm going to share my screen now.
Okay.
Yeah.
Okay, great.
And then we can also send this information over to you. And if we have details and you have a way of shooting this over to the audience, we'd be happy for them to have the details.
Absolutely. I can go ahead and post it on the meetup and also out on LinkedIn. And I'm sure people would greatly appreciate this. This is a time, I can't think of a different time when IoT is more important than right now. We're in the middle of COVID. And we have everybody working from home. I can't think of a more opportune time or the need or the necessity for censoring up different assets, people, buildings, locations, so that you can remotely monitor and in some cases remotely control. So this is a very, in my opinion, a very valid topic. And just as we have online shopping that has kind of jumped forward in adoption, more and more people are doing it because they have to be home or they have to order things online, they have to get their food online. I think IoT, there's a lot of opportunity in IoT, especially right now, and I see the opportunity to really pull this technology and adoption is really becoming more and more important and more relevant. Anybody have any closing comments or anything they want to say for the group? Anything to add?
I would just say great session. Thank you guys very much. Awesome.
Sure.
Thanks, Brian. Thank you, guys.
Thank you, everybody.
You guys, again, thank you for presenting. Thank you for your time. And thank you to everybody that participated today. Greatly appreciate it. This is recorded.
Absolutely.
Recording out onto the meetup site. And again, thank you.
Thank you.
Great.
Bye now.
Thank you, Shannon. Thank you, everyone.
Thank you. Good presentation.
Great job.